Question 7, Part A. Gareth is running a game stall at his school fete. In his game, a player must flip a coin and spin a fair four-sided spinner. The sections of the spinner are labelled 1, 2, 3 and 4 as shown below. So you have a coin that has a head or a tail and a spinner that has 4 numbers on. Part 1. Write down all the possible outcomes. One has been done for you. So if we work through systematically getting heads first on the coin, so we've got a head and then spinning a 1 on the spinner. We could have a head and then spinning a 2 on the spinner, a head and a 3 on the spinner, a head and a 4 on the spinner. We then also could flip a tail and have a 1 on the spinner, tail, a 2 on the spinner, tail, a 3, and tail, a 4. So that's it for 2 marks. You have to have at least 4 correct outcomes. For 1 mark, in addition to this head 1. So a player wins a prize if the coin lands on tails. A player wins a prize if a coin lands on tails and the spinner shows the number 4. He plays the game once. What is the probability that Azzy wins a prize? So the options are tails, so it can be these, and the number 4. So we have tail and 4. Only this option here would give Azzy a prize. So when we're doing probability, we have the total outcomes on the bottom. And on the top is the successful outcomes. So for Azzy to win a prize, he has to have this, which there's only one of them, over the total outcome. So that's all of these. So 1, 2, 3, 4, 5, 6, 7, 8. These are all of the things that could possibly happen. So 1 over 8. So the examiner will give you 1 mark. If you have denominator as 8 and 1 mark as a numerator of 1. If you have 1 out of 8 written in words, that will only give you 1 mark in the mark scheme. You have to show that probability can be written as a fraction. So question 7, part B. Keris says the chance of throwing a 3 on an ordinary 6-sided dice is higher than the chance of throwing a 6 because 6 is the hardest number to get. Is Keris correct? Explain your reasoning fully. So as we said here, the probability is total outcomes underneath. So there are 6 total outcomes you can have on a dice, 1, 2, 3, 4, 5 and 6. And then the successful outcomes on the top. So each number only comes up once. 1 comes up once, 2 comes up once, 3 comes up once, and so on. So therefore, every number on a die has a 1 in 6 chance of coming up. So you need to explain your reasoning fully now. So Keris is not correct. Because each number has an equal chance of being thrown. Or you could say each number has a 1 in 6 chance of being thrown.